Hey there guys, this is Danielle. I am making this video today as a review of our Chapter 2 problems in calculus. These are some problems that I selected with my teacher that people are having issues with, and so I'm making this video today to maybe give you some more insight or help into solving these problems. So in the first problem that I picked out today, we're solving for the limit as x approaches 2, specifically from the negative. In our equation today, one of the major issues that people have trouble with is that it has an absolute value function. So we have the absolute value of x minus 2 over 2x minus 4. So before we really get into trying to solve the equation, I think it's good to try to kind of visualize what we're needing to solve here. I personally did actually imagine this in my mind before I was able to continue. And, you know, if that is something that helps you, I think it's good to just take a look at that. So what we do know here, I think everybody feels very comfortable with the line x minus 2. You know, we know that if we plug in 2, we'll get 2 minus 2. So that's our 0 at x equals 2. And then x alone is just going to have a slope of 1. So we go to our 2, and we're going to have a line with a slope of 1 going up this way. I kind of like the bigger line, so let's go ahead and make a bigger line. Okay, awesome. Good. We're very happy there. And then the regular line, x minus 2, would go ahead and continue downwards here to negative infinity as well. But with our absolute value, what that means is we're trying to find out what the distance is from the x-axis, basically. It's always going to be a positive number. So we really need to take those negative values, and we're just going to go ahead and like flip them over our x-axis like that. So let's get rid of that bottom line there. And there we go. Because we're really just asking, okay, if we took that line down here, you know, here at 1, we would have the answer as negative 1. So if you put in 1 here, you know, 1 minus 2 is negative 1. But if we take the absolute value of that negative 1, then that's how we get this point here being 1 instead of negative 1. So if you, you know, kind of have that in mind, something that it's just really important to go ahead and kind of visualize and realize that that's what's happening. Because once you realize that, you know, if you look at this line here, some things that are different is our original line had its x-intercept at negative 2, and this one has its x-intercept at positive 2. So we know that our y-intercept is at positive 2. And then this line, instead of having the positive slope of 1, has a negative slope of 1. So that would be negative x. If you notice, if you take x minus 2 and you take the opposite of x minus 2, well, hey, that's this line right here. So really, if we want to try to solve for the limit, and we're only looking, oh, one more. We're only looking to solve for this side, we need to go ahead and rewrite this as the limit as x approaches 2 from the negative of the opposite of x minus 2 over 2x minus 4. So what we're doing, if we needed to solve this for just the limit as x approaches 2, we would also need to go ahead and solve the limit as x approaches 2 from the positive of x minus 2 to x minus 4, because when we're on the positive side of 2, our function, it basically is a different line. You know, it's that line x minus 2 rather than the line opposite of x minus 2. So that's why we are rewriting this equation to be the opposite of x minus 2. Once you have that, really this problem is pretty easy from there, because then we can just take our limit as x approaches 2 from the negative. Of course, we're going to keep that up there on top. And then you can go ahead and down here, we can just pull out a 2. We'll have x minus 2, and we'll look at that. Our x minus 2 will divide out. We'll be left for the limit as x approaches 2 from the negative of -1 over 2. And so there we are. There is our answer. So as long as you can just remember, anytime that you have an absolute value, just remember that you're going to need to solve this as a piecewise function. Anything in that function that would normally be negative is now going to be positive. So it's very easy when you have a line, but you may have to remind yourself to kind of take a step back and sketch things out if maybe, it's x squared minus 2 or, a different absolute value equation. You just need to remember to split things up so that any time that you have your function normally being negative, we're going to have to rewrite that so that way those values are positive. And then you can go ahead and solve for the limit at that area.